x, take away 10x. If you got 21 something, take away 10 of that thing, you're left with 11x. Again, if I was left with the same letter on the top and the bottom, I might be able to cancel out, possibly like back up here with our index laws. You might need to cancel that way. Or if there's a number that goes into both 11 and 35, they could cancel out possibly. If you're not sure, if you really struggle thinking about factors, what you could do is you could type without the x, just 11 over 35 into your calculator, hit equals, make sure it gives you a fraction answer, not a decimal. And if it gives you 11 over 35, that means it can't be simplified. If it gave you like 2 over 3, for example, that would be the simplest form. Cool little trick. Okay, I'll quickly go through 10. So the trick here is that you've got a whole number. Now, a whole means it's like over 1, if that helps you to think about it. And then we treat it the same way. We need these sizes to be the same. You go, what number do 1 and 7 both go into? Clearly 7. So I don't need to touch that right side at all. I can leave them alone. But I'm going to need to times this side by 7. If I times the top by 7, I'm going to get negative 63x over 7. And remember, I didn't need to touch that right side at all. Now that I've got it like this, 63, take away 5 more, should get you negative 68x over 7. And then I don't think 7 goes into 68. I may be wrong there. But again, we're just trying to simplify numbers if they go in. If you're not sure, you could type that into a calculator. So now when we do multiplying is way easier than adding and subtracting, and so is dividing. So when you multiply, you basically do what you would want to do when you add, which is just go across the top, across the bottom. So if I go across the top, I've got C times D. That's just CD. We just don't write the times. Across the bottom, 3 times 2 is 6. Done. For this one, we're going to be able to do some simplifying and some cancelling. There's 2 options. You can be proactive and do your cancelling at the start, or you could get your answer and cancel at the end. Genuinely, either is fine, whatever you prefer. I might cancel at the start and then go through and do it the other way. So if you were to cancel at the start, what you're going to notice is I can't cancel y over x or x over y. But when we multiply, it's all going to end up over each other anyway. Okay, so you could notice that this y is going to cancel with that y, and this x is going to cancel with that x, because they're all going to end up over each other when we multiply. Now it's all just numbers. You could get 8 times 9, which is going to be 72, I think. Oh, it's been a while since I've done maths, over 35, and that would be your answer. Again, you could get a mixed number here. That would be 2 and 2/35. If you're not sure how to do that, you could also do that on your calculator. Again, my maths is probably off here because we're a bit dodgy, but you could just type that whole thing into your calculator, hit equals. Again, in fraction mode, it will give you the simplest answer. Now, if you get a improper fraction, like this is, where the top number, the numerator, is bigger than the bottom number, you could do it in your head and you could say, well, how many 35s go into 72? I know 2 35s is 70, so that must be 2, and you got 2 left over. That's how you do that in your head. If you aren't too confident with that, you can go to your calculator and you'll see where there's that fraction to decimal button, just above it in yellow, there should be like a little mixed fraction button. It's in yellow, so you got to hit shift and then that button, and it will actually turn your fraction into this mixed number as well, which is kind of cool. So if you did it the other way, we'll do this in red now. If I just go across the top, across the bottom, cancel out the end, I'd get 72xy over 35xy. And then I just need to realize, oh, cancel, 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 cancel. And I get the same answer. And you can do that fraction trick the same way. Okay, so when I divide, it's basically the same. There's one thing I have to do first. So the trick with dividing is if you think about 6 divided into 2 groups, that's the same thing as saying 6 times a half. Now, what did I do there? I flipped the divide into a times, but when I do that, I need to do the reciprocal, which just means flip the fraction of that divisor, the second part, the second number. So you could imagine that 2 is over 1. We can always imagine that with whole numbers. So then I've changed it to a times, and I have flipped that fraction. That's called a reciprocal. So if I was doing like 6 divided by, let's say like 1/3, when you divide by a fraction, it's actually going to get bigger. So that's the same thing as 6 times. And if I was to flip 3 over 1, get the reciprocal, 1 over 3, I would end up with 3 over 1, or just 3, which would get me an answer of 18. So it's actually bigger. So that's the main idea here. When we divide with fractions, we're just going to turn it into a multiplication problem. So the first thing always stays the same because that's the amount we are dividing. And then we change our divide into a times. And then I'm just going to flip, do the reciprocal of that second term. So I'm going to get 96u over 5v cubed. Now that's probably looking quite intimidating, because it is quite intimidating and it's quite gross. There isn't actually much that's going to cancel here. What I could do is I could look, all right, well, I can't cancel anything here. Does 8 go into 32? I'm pretty sure it does. 8 goes into 32, well, 1 8 goes into 8, and then 4 8s goes into 32. So at least I can simplify that bit. That might help. Again, you could leave that simplifying and just do it at the end on your calculator. We might do that, but you could have simplified it as well. So if I go across the top, I definitely need a calculator for this, or I'm going to lose my brain. So we're going to go 8 times 96, and we are going to get 768. And then I've got u cubed times u, so I'm going to get u to the 4. On the bottom, I'm going to get 32 times 5. Well, 5 times 30 should be 150, so I should get 160 v to the 4. And then you go, oh, well, can that simplify? Actually, I do need my calculator. And then you're going to go onto your calculator, you're going to type in just the numbers, because the algebra, the letters aren't going to cancel, and we can't do them in our calculator. So 768 over 160 on your calculator, hit equals, and I get 24 over 5. Now you need to remember to still write in the algebra, even though we can't do that on our calculator. And that's kind of done. If you wanted to, you could, actually I'm not going to tell you to do that, sorry. Technically that's an improper fraction. The reason I'm not going to write it as a mixed number, being 4 4/5, is because it's going to get really messy when you put like the 4 out the front and then blah, blah, blah. Don't break up an algebraic fraction into a mixed number, because it's just going to cause you havoc. Okay, so 14 and 15, they are both involving negative powers. The thing with a negative power is they're unhappy because they're not in the right spot in the fraction. So if you have a negative power and it's on the numerator on top, then it needs to go on the other part, so on the bottom. So all that means is, imagine there's a 1 out there, we're going to leave that 1 on top, and that a is going to go to the bottom. It's going to keep the size of the power, so it's still a 9, but now it's happy because it's on the right spot. So when I do, I'll show you another quick example here as well. If I had 1 over a to the minus 4, and that was my, I shouldn't write equals, that's my question, and I want to write it with a positive power, that just means put it in the right spot. It's not happy because it's on the bottom, so I need to write him up on top. And you could write over 1, but we know that that doesn't actually mean anything. Okay, so for this one here, the trick with this question is that we're doing power of powers, and we have a number and the algebra, so there's a bit to keep track of. So if you do the number first, you're going to have 3 to the negative 2, because remember that 3 is its own thing. And then I've got y, and now these powers are going to multiply together. So I'm going to get y to the minus 4. Now, a couple of things to notice here. They're both unhappy because they're both in the wrong spot. If I had 3 squared, y to the minus 4, that 3 squared would stay on top, and y to the 4